Unimaginable. Hey everyone, imagine a world without computers. No digital screens, no internet, no social media. It's almost impossible to fathom, right? No smartphones, no laptops, no video games. Can you even imagine? Today, computers are everywhere. They have become an integral part of our daily lives, seamlessly blending into our routines. They're in our pockets, on our desks, and even in our cars. From the moment we wake up to the time we go to bed, computers assist us in countless ways. They help us communicate, work, learn, and even entertain ourselves. But it wasn't always like this. There was a time when computers were massive machines, occupying entire rooms and requiring teams of people to operate them. They were slow, cumbersome, and limited in their capabilities. We've come a long way from simple counting machines to powerful computers that can process massive amounts of data in the blink of an eye. The journey of computing technology is a fascinating tale of innovation and progress. So buckle up as we take an epic journey through the history of computers, from the abacus to quantum computing. We'll explore the milestones that have shaped the digital world we live in today, and look ahead to the future of computing technology. From the earliest mechanical calculators to the latest advancements in artificial intelligence, this journey will highlight the incredible evolution of computers and their impact on our lives. Get ready to be amazed by the ingenuity and creativity that have driven the development of these remarkable machines. Let's dive into the world of computing and discover how it has transformed our world in ways we could never have imagined. Many people think the first computer was invented in the 1900s. This belief is quite common, especially when we consider the rapid advancements in technology during the 20th century. The image of large, room-sized machines with blinking lights and whirring tapes often comes to mind. These early electronic computers like ENIAC and UNIVAC were indeed groundbreaking and set the stage for the digital age we live in today. However, the story of computing goes back much further than most people realize. But guess what? It was actually invented thousands of years earlier. The history of computing is rich and fascinating, stretching back to ancient civilizations that sought ways to simplify calculations and record information. These early innovations laid the groundwork for the complex machines we use today. From the ancient Greeks to the Chinese, many cultures contributed to the evolution of computing. The abacus, a simple counting device, is considered the earliest form of a computer. This ingenious tool, which dates back to around 2400 BC, was used by various ancient civilizations, including the Sumerians and Egyptians. The abacus allowed users to perform arithmetic operations quickly and efficiently, making it an essential tool for merchants, traders, and scholars of the time. It used beads on rods to perform calculations. Pretty cool, right? The design of the abacus is both simple and effective, with each bead representing a different value. By sliding the beads along the rods, users could add, subtract, multiply, and divide numbers with ease. The abacus remained in use for centuries and is still used in some parts of the world today, a testament to its enduring utility. Centuries later, a brilliant mind named Charles Babbage designed the analytical engine. Born in 1791, Babbage was a mathematician, philosopher, and mechanical engineer who is often referred to as the father of the computer. His vision for the analytical engine was revolutionary, as it was designed to be a general-purpose computing machine capable of performing any calculation. This mechanical marvel was designed to perform complex calculations using punch cards. The analytical engine featured an arithmetic logic unit, control flow in the form of conditional branching and loops, and integrated memory, all of which are fundamental components of modern computers. Babbage's use of punch cards, inspired by the Jacquard loom, allowed for the automation of complex calculations and data processing. Although never fully built during his lifetime, Babbage's analytical engine laid the foundation for modern computers. His pioneering work inspired future generations of inventors and scientists, including Ada Lovelace, who is often credited with writing the first computer program. The concepts and designs proposed by Babbage continue to influence the development of computing technology, proving that his ideas were truly ahead of their time. Early computers were massive machines that took up entire rooms. They used gears and vacuum tubes, which were bulky and unreliable. But then came a breakthrough: the transistor. This tiny device could control the flow of electricity much more efficiently than vacuum tubes. The invention of the integrated circuit, or microchip, was another game changer. It allowed engineers to pack thousands of transistors onto a single chip, making computers smaller and more powerful. In the 1970s and 80s, companies like IBM and Apple introduced personal computers, making computers accessible to everyone. These early PCs used operating systems like MS-DOS and later, Microsoft Windows. Remember the days of floppy disks and dial-up internet? The invention of the graphical user interface, or GUI, made computers even more user-friendly. With icons and windows, you no longer needed to type complicated commands. Section 5. Connecting the world, the Internet and mobile boom. The Internet, a global network of computers, revolutionized the way we communicate and access information. Then came smartphones, putting the power of a computer in our pockets. Now we could connect with anyone, anywhere, anytime. Cloud computing emerged, allowing us to store data and access software over the Internet. And with the Internet of Things, everyday objects are becoming connected, making our lives more convenient. Section 6. Artificial Intelligence making computers think. Artificial intelligence, or AI, is transforming the way we live and work. AI systems can learn from data, make decisions, and even perform tasks that typically require human intelligence. Machine learning, a subset of AI, enables computers to learn without explicit programming. Deep learning, a more advanced form of machine learning, uses artificial neural networks to analyze vast amounts of data. Section 7. Supercomputers and beyond, the quest for more power. Supercomputers are the giants of the computing world, capable of performing quadrillions of calculations per second. They are used for scientific research, weather forecasting, financial modeling, and more. GPUs, originally designed for graphics processing, have become essential for AI and supercomputing. Quantum computing is another exciting frontier. These computers use the principles of quantum mechanics to solve problems that are impossible for classical computers. Section 8. Quantum computing, a leap into the future. Quantum computers are still in their early stages of development, but they have the potential to revolutionize fields like medicine, materials, science, and artificial intelligence. Imagine a world where complex problems that take classical computers thousands of years to solve can be tackled in mere seconds. This is the promise of quantum computing. Researchers are working tirelessly to overcome the current limitations and unlock the full potential of this groundbreaking technology. Unlike classical computers that use bits, quantum computers use qubits. Bits, the fundamental units of classical computers, can exist in one of two states, 0 or 1. Qubits, on the other hand, can exist in multiple states simultaneously, thanks to the principles of quantum mechanics. This unique property of qubits is what gives quantum computers their extraordinary computational power. Qubits can exist in multiple states simultaneously, allowing quantum computers to perform calculations much faster. This phenomenon, known as superposition, enables quantum computers to process a vast amount of information at once. Additionally, qubits can be entangled, meaning the state of one qubit can depend on the state of another, no matter the distance between them. This entanglement further enhances the computational capabilities of quantum computers. Companies like IBM and Google are at the forefront of quantum computing research, developing new hardware and software for this revolutionary technology. These tech giants are investing heavily in quantum research, aiming to create practical and scalable quantum computers. Their efforts are paving the way for a future where quantum computing could solve some of the world's most challenging problems, from drug discovery to climate modeling. The journey is just beginning, but the potential impact of quantum computing is truly limitless. Section 9. The future of computers, what's next? The journey of computers is far from over. As technology continues to advance, we can expect even more powerful and versatile computers in the future. Quantum computing, artificial intelligence, and edge computing are just a few areas that hold immense potential for innovation. So, what are your thoughts on the future of computing? Share your comments below and don't forget to give this video a thumbs up.